Hello everyone, today I will present my study on a reliability analysis of reinforced concrete beam comparing form and Monte Cristo simulation. So this work aims to address a critical question: how can engineers balance speed and accuracy when assessing structural reliability? So let's dive in. First, the introduction. The reinforced concrete structures, like buildings, bridges, or dams, are fundamental to modern civil engineering. However, their reliability is challenged by uncertainties in material properties, like the concrete strength Fc or the steel yield strength Fy, and the applied loads. So traditional deterministic methods, such as the Orocode 2, provide safety factors but don't account for the probabilistic nature of these uncertainties. So this is where the probabilistic reliability methods like the Form 1 or the Monte Carlo simulation 1 come into play. They explicitly model uncertainties and calculate failure probabilities Pf and reliability indices beta. So our study had three clear objectives. First, apply the form and MCS methods to reinforce concrete beam under random loads. Second, compare the reliability index beta and failure probability Pf obtained with each method. And the last point, discuss the advantages and limitations of each method supported by the literature I studied for this project. So for the methodology overview, we followed this structure. First, the literature review of three key studies comparing form and MCS method. Secondly, the numerical application, where we are gonna define beam geometry, loads, and random variables, and after implement the form and MCS method. Third, the results and discussion, so compare beta and Pf, analyze sensitivity to material uncertainty for each method. And for the last point, the conclusion, where we're gonna summarize findings and provide practical recommendations. So about the literature that I studied for this report, first we had the strip-stack document where they compared form, SORM, and MCS method for reinforced concrete foundation. So here the result we obtained. So we can see that the MCS provides a more conservative PF, but is computationally expensive. This means the cake will take times with this method. About the second document, the Nguyen one, this document applied MCS to a composite steel reinforced concrete beam. So here is the results, and for the conclusion, we can say that the MCS method is essential for capturing uncertainties in composite structures. And the last document, the El Gulburi one, compared form and ESM. ESM is a developed MCS method, like a new one, for four-floor reinforced concrete building. So we can see with the results that the form has to overestimate the PF, but is 180 times faster than the ISM method. So to compare this analysis, we can say that the studies show that the discrepancy between form and MCS depends on the nonlinearity of the limit state function Jx. For example, for the linear problems like the beam bending, the form method may underestimate PF, but for the nonlinear problems like the foundation stability, the form method may overestimate PF. So this context sets the stage for our study on reinforced concrete beam. So about the methodology now, Our study focuses on a reinforced concrete beam designed according to R&RA 2 with the following properties. So first, the geometry and the materials, as you can see, 6 meters for the length, a cross section 0.3 times 0.5, for the reinforcements, 4 steel bars, and 40 millimeters concrete cover. About the materials, we took regular concrete and regular steel values. And about the random loads, same. I took the regular values that we can find on Eurocode or something like this. So about the limit state function now, we define Jx equal to mr minus ms, where mr is the resistant moment that we can find in the Eurocode 2, and ms the soliciting moments. I write the formula just here. So with the value we introduced previously, we obtained for Jx0 8.3 kilonewton by a meter. So we can say that it's safe for this example. And for the methods used, the form, so the first order reliability method, we used the Haushofer-Lin algorithm for a fast linear approximation. However, the Monte Carlo, we used 10,000 simulation for precise PF estimation as much as we can. And then we can dive in the results after this, after using these two methods. So here are the key results of our study. So the comparison of form and Monte Carlo in the table 6. We can say that the form underestimates PF by 42% compared to the Monte Carlo method, with really precise compared to the form one. So this precision has a cost because the Monte Carlo is 100 times slower than the form one. And for the reliability index beta, with the form method is equal to 2.8, that aligns with the initial safe state, where Jx0 is equal to 8.3 Newton by meter. So then for the sensitivity analysis in the table 8, we can understand that my interpretation after this change, after the changement in the sensitivity values, that an iter concrete strength variability, so CVFC, significantly increased the probability failure, PF, and the 42% underestimation by form is consistent with literature for linear, mildly nonlinear problems. So now for the comparison with literature, so with the three topics I studied for this report in the table 7, our findings confirm that the form underestimates PF for linear problems, while it may overestimate PF for non-linear problems. Now, for the discussion part, we can ask ourselves, why does the form underestimate PF? So form uses a linear approximation of the limit state function Jx, which misses either order effects. This aligns with literature, because for linear problems like our beam, the form method underestimates PF, like in the L. Gulbzuri reports, And for the nonlinear problems, like in the foundation problem, form may overestimates PF, like in the strip-Zach topic. So for the practical implication for engineers, we can say that we have to use form for preliminary design. It's fast and conservative. We have also always validate with Monte Carlo for critical structures like the bridge, the high-rises buildings. And third point, we have to focus on reducing material uncertainty to improve reliability indices beta. Then there is limitation and some question on the future work about this report. So our study assumes independent random variables, which means in the future work we could explore correlation, for example, between FC and Fy factors. We can also extending the analysis to other structural elements like slabs, columns, will provide a comprehensive risk assessment. And finally, try an hybrid method, like using form and Monte Carlo simulation refinement, we could balance speed and accuracy. So I think we finished to talk about this report. The conclusion, try to summarize all the results we obtained before. Then thanks you for your attention. If you have any question on how this method could apply to your projects, I can answer them. And that's it. Thanks.